Welcome to this session. This session, we are going to give an example on how to find or how to evaluate limit of a function of two variables, x and y. So here's the problem. Evaluate limit x squared y over x power 4 plus y squared, x approaches 0, y approaches 0. So to solve this, you have to remember the first steps we stated earlier on how to solve limit of a function of more than one variable as both the values of x and y approaches 0, 0. So step 1, we put x equals to 0, then y equals to 0. This is what we mean. You write limit x approaches 0, y approaches 0 of x squared y, x power 4 plus y squared. You write it as limit y approaches 0. Now you start with the part with x. Limit as x approaches 0 of x squared y, x power 4 plus y squared. Now here in this square bracket, you do direct substitution. So you write limit y approaches 0. Where there's x, we put 0. So we'll have 0 squared y, and then 0 power 4 plus y squared. Now 0 squared is 0. When you multiply by y, you get 0. So that we'll have limit y approaching 0 of 0 over y power 2, which is the same as limit as y approaches 0 of 0, and limit of a constant is a constant. And then you let this value to be the f1. Step 2, now you reverse what you did in step 1. You start by put y equals to 0, then x equals to 0. This is what you mean. You write limit x approaches 0, y approaches 0, x squared y, x power 4 plus y squared will be limit. Now x approaches 0. Now you start with y. Limit y approaches 0 of x squared y, x power 4 plus y squared. You start by solving what is in the square bracket by replacing where this y by 0. We'll have limit x approaches 0 of x squared by 0, x power 4 plus 0 squared. And when you multiply x squared by 0, you get 0. So we'll have limit x approaches 0 of 0 over x power 4. And 0 over x power 4 is 0. So limit as x approaches 0 of 0 is 0. So call this one f2. Now, since f1 and f2 are the same, you go to step 3. Since f1 equals to f2 equals to 0, then we go to step 3, i.e. step 3 now, you put y to be mx. So this means that the limit as x approaches 0, y approaches 0, the function is x squared y over x power 4 plus y squared will be now limit. So just have a single variable x, and this will be x squared, while this y you put mx, and then x power 4 plus mx squared. So this is the resulting function, which will be limit x approaches 0. Now we factorize x squared into mx. Denominator will be x squared into x squared plus m squared, so that we can cancel this x's. So this x squared and x squared cancels out. So we'll have limit x approaches 0, mx over x squared plus m squared, which is given by direct substitution will be m times 0, 0 squared plus m squared, which is 0 over m squared, which is 0. So call this one F3. So the value of F1, F2, and F3 are the same. So it allows us to go to the last step, step 4. So since F1 equals to F2 equals to F3 equals to 0, then we go to step 4. So step 4, now you approach the point through the parabola y equals to mx squared. So which means the limit x approaches 0, y approaches 0, x squared y, x power 4 plus y squared will be limit x approaches 0, x squared, where this y you put mx squared, x power 4 plus mx squared power 2, which will be, this time round I can factor out x power 4. So x approaches 0, x power 4 into m divided by x power 4 into 1 plus m squared. So x power 4 cancels out, so that I have this will be limit x approaches 0 of m over 1 plus m squared. Now, because there is no x here, so this limit will get the same as the same constant, m over 1 plus m squared. So this is our F4. So m can be any real number. So since m can be any real number, then F4 is different from F1, F2, and F3, i.e. F1 equals to F2 equals to F3 is not equals to F4, and hence, because all the 4 properties are not satisfied, then the limit of the function as x approaches 0 y approaches 0, does not exist. So for it to exist, then all the f1 up to f4 should be giving the same value. But because the supposability of getting a different value for f4 from 0, like the 0 will only be possible when you set m to 0. But because m can be any real number, then it shows that this can take on different values apart from 0. So because of that inequality, then limit does not exist. So that's how we do that problem. Thank you.